teacher at Sanger Ridge Elementary and an OERB master teacher. Today's lesson, Buoyancy is Fun, Sink or Float, is brought to you by the people of Oklahoma's oil and natural gas. Let's get started. Have you ever wondered why a penny sinks in water, but large ships and boats can float? I'm sure you've noticed while you are swimming in a pool or taking a bath that some objects float while other objects sink. That's because the light objects float and the heavy objects sink, right? Not exactly. If that were the case, all ships and boats would sink. Let's explore sinking and floating some more. I've gathered some items from around my house for us to test. I've also attached a worksheet called Sink or Float. Now would be a great time to print it and grab a pencil so we can begin. Pause the video if you need to. Now that you have your worksheet and a pencil, I've gathered some objects from around my house for us to test. Let's start by recording the names of the objects we're going to test in the objects column of our worksheet. We have a rock, a golf ball, a tennis ball, a sponge, a pencil, a plastic spoon, a metal spoon, and foil. Once you have the objects written down, your worksheet should look similar to mine. Now that we have our objects written down, we're ready to make a prediction on whether we think the objects will sink or float. A prediction is a guess about what we think the outcome will be. We might make a prediction based on experiences that we've had or observations we've made in the past. So take the first object, a rock. Do you think the rock will sink or float? If you think it will sink, put an S in your prediction column. If you think it will float, put an F. I put an S because I think the rock will sink. Go down the list writing S or F, making predictions on what you think the outcome will be, and then we will begin testing. Now that we have made our predictions, we're ready to test our objects. We're going to start by placing a rock in the water. Did that rock sink or float? We know that that rock sank, so we are going to put an S in the sink or float column of our worksheet. Now, let's try a golf ball. The golf ball sank, so write an S in the sink or float column. Next, let's try out this tennis ball. I wonder if your prediction will be correct. Wow, that tennis ball is floating, so write an F in the column for sink or float. Now let's try a sponge. That sponge is definitely floating, so write an F in the column. Next, we have a pencil. Pencil is made out of wood. It appears to be floating. Put an F in the column beside pencil. Next, let's try a plastic spoon. Scoot you over a little bit. Our plastic spoon is floating, so write an F. Next, I have a metal spoon. It sank. Write an S. And lastly, I have a piece of aluminum foil. Move some items out of the way here. The foil is floating. So let's write an F for float beside aluminum foil. That's a lot of objects floating and quite a few objects that sank. Let's take a closer look at these two objects. You can see that the large object is floating while the small object has sank to the bottom. This is because of density. If an object is more dense than water, it will sink. If an object is less dense than water, it will float. Density is the amount of matter or stuff inside of an object. So the tennis ball has less matter, so it is less dense than water and is able to float, while the golf ball has more stuff inside. It is more dense than water, and therefore it has sank. Did you notice every time I placed an object in this container, the water level rose? Maybe not, but I bet you have put ice in a cup of liquid before, like Kool-Aid or water. Did you see the water level rise in the cup? This is known as displacement, and displacement was found by a scientist named Archimedes when he was taking a bath. He noticed when he submerged his body into the water, the level of the water rose around him. So when an object is placed in water, the water moves and is displaced, and that's what causes the water levels to rise on the side. We've learned some interesting things about objects that float and sink in water. In this next part, we are going to design our own boats that float. We describe something that floats as being buoyant or having buoyancy. In this activity, you'll need to gather some things from around your home. You'll need a large container of water, a ruler, scissors, aluminum foil. Your aluminum foil will need to be cut into two 6-inch by 6-inch squares. You'll also need quite a few pennies. Pause the video, gather your materials, and when you get back, we'll begin. In this activity, we will be designing 2 aluminum foil boats. Be sure each boat has a different shape and design. Let's start by taking a minute to draw out our boat design plan on our worksheet. Pause the video, take as long as you need to draw your plans, and then we'll resume. Now that you have a plan, you're ready to start building your boat. You may not use any other materials to build your boats, and be careful not to tear the foil. Once you're done building your boats, use the worksheet to make a prediction as to which boat you think will hold the most pennies before sinking. Take as much time as you need to build your boat and make your predictions, and join me when you're ready. Those are some great looking boats. Which one did you predict would hold the most pennies before sinking? Let's find out if your prediction was correct. It's time to finally discover which boat is the most buoyant. To start, gently place your boat in the water and place 1 penny at a time into your boat. Be careful to evenly distribute the weight on your boat as you go. Once your boat begins to take on water, remove the boat, count your pennies, take the data that you collected and report it on your data table here in the worksheet. Repeat this whole process with your second boat when you're finished with the first, and be sure to record your data. I'll see you back in just a minute. Welcome back. Here are the boats I made. So what did you find out? Was boat 1 or boat 2 more buoyant? Did you make some interesting observations? Here are some questions to think about. How many pennies was each boat able to hold? Did it matter how aware you placed the pennies? What shape or design of boat worked the best? What could you do to make your boat hold more weight? Did your boat tip over before it sank? If so, what changes could you make to fix this? So let's discuss what happened in this activity. In order for our boats to float, the weight of the boat had to be less than the weight of the water the object was displacing or pushing aside. There are 2 primary forces that acted on this science activity. The first force was gravity. Gravity is trying to pull the aluminum foil and the pennies downward. The force of buoyancy is pushing up towards the surface. The gravitational force is determined by the mass of the aluminum foil and the weight of the pennies on the boat. The force of the buoyancy is the weight of the water displaced by the boat. Your boat will continue to float as long as the force of buoyancy is greater than the force of the gravity, and your boat weighs less or is less dense than the amount of water the boat is displacing. Just like with the household items we tested earlier, as long as the amount of water displaced by the object is greater than the weight of the object, it floated. But if the weight of the object is more than the amount of water displaced by the object, it sank. Only when gravitational force is less than the buoyancy force can an object float. Well, I've had fun hanging out with you today. I hope you've had fun learning about buoyancy. I do have one more challenge for you, and that is to design an even better boat. Using another piece of foil, can you improve your design to hold even more pennies? Predict and test your new and improved boat and let us see it. If you take a picture of your boat and email it to teachers@oerb.com and post it on Facebook or Instagram @OERBOK, you could win a prize. I hope to see your new and improved design. Bye.